Titan fans and engineers, welcome to the tutorial video on how to set up the Titan SVX ETH using a rotary stepper motor. In this video, we will take a look at how to set up a rotary stepper motor so that we can do a closed-loop control on it. When you run a stepper motor in closed loop instead of the commonly used open loop, you will get higher performance and a quieter, cooler running stepper motor. What we have here is a NEMA 23 stepper motor with an encoder on the back. Let's connect the motor and the encoder to the Titan controller. For wiring and pinouts information of the motor and encoder connectors, you can check out the hardware manual of the Titan SVX ETH. Let's power on the controller and see the LED and blue RGB light up. Connect the Titan to the PC using a USB cable and confirm the communication on the Titan software. You can also use the RS-485 communication method. You can check out our other tutorials on how to do this. Next, let's open up the motor setup window. This window shows all the information we need about the current motor, such as the motor name, motor type, encoder information, motor electrical parameters, and motor mechanical parameters. To set up a new motor on the Titan, there are two options. You can use the previously determined motor database file and download it to the Titan, or you can use the motor database wizard to create a new motor database file. In this example, we will use the motor database wizard to create a new stepper motor profile. Select the MDB wizard button and consent to proceed. Here, it shows all the different types of motors that can be used with the Titan. Let's select a rotary stepper motor. Next, let's enter the name, voltage, and max current of the motor. In this example, we are using a NEMA 23 double stack motor. So we will name the motor Arcus STP23-2. We have a 48-volt power supply here, and for the current, we will enter 2 amps. You can check if the encoder is working by rotating the shaft manually and seeing the position change. Once everything is confirmed and filled in, click the Next button. We will now perform the auto detection routine. Before performing the routine, make sure the motor shaft is free and not connected to anything. Also, the motor should be held down manually or mounted on a stable location, since the auto sequences will perform small, quick motions. Once the motor is free and secured, select the Auto Detect Sequence button. Here we go. First will be the detection of the encoder count. Encoder count detected is 16,000 per revolution. Second will be the detection of the stepper motor electrical parameters, which are motor constant, resistance, and inductance values. The next sequence will be the detection of the stepper motor mechanical parameters, and they are motor inertia, coulomb, and viscous friction values. Once the detection is successfully done, go to the next screen. Save the motor parameters to a motor database file so that the database can be used again later. When naming the database file, give a useful description name so that you can easily know the motor information in the database. Motor parameters can be stored to the flash so that after the power cycle, the current motor parameters remains on the Titan. If you want to use the same motor type on another Titan, you can simply download the motor database file to that Titan controller. Now, let's test the motion of the motor by navigating to the Test Drive panel. The first step will be to enable the motor using the Enable button. After that, you can set the gain of the motor. The easiest way to do this would be to use one of the preset gains available: 1, 2, 3, 4, and 5. A preset gain of 1 will have a very loose control over the closed-loop feedback, and a preset gain of 5 will have very tight control. Check the Current Gain Update checkbox as well, so that the current gain is also set along with the performance gains. In this case, we will use a preset gain of 3. Okay, so to quickly test motion, you'll first want to define the speed being used for the motion. In this case, we'll use a speed of 200. The unit of the speed will be in RPMs. You'll also want to define the acceleration of the motor during motion. We will use an acceleration of 5,000, which is in the units of RPMs per second. Jog plus will rotate the motor in the positive direction, and jog minus will rotate the motor in the negative direction, like that. You can also move to target positions. Let me show you what that would look like. The first target position will be the position of 0. We will move at a target speed of 300 with an acceleration of 2,000. The second target position will be 100,000 with the target speed of 500 and an acceleration of 3,000. First, move to target position 1 and back to target position 2, and we can cycle back and forth between these two positions. Okay, we are done with the stepper motor setup on Titan, and we were able to do some quick motion testing. I hope the tutorial video was helpful and showed how easy and quick it is to set up a motor on a Titan. Don't forget to check out our other tutorials on how to set up BLDC, voice coil, and linear motors as well. Thanks for watching, and happy servoing!